All right, 12.2b, geometric series. We're also going to do sequences from 2 points. And sequences from 2 points. Okay? Now, we've already talked yesterday about geometric sequences, right? What does it mean to be a finite sequence? It has an end. It doesn't go on forever. An infinite sequence has ... meaning it's going on and on and on and on, right? So that we should know. Let's start off with this right here. Is this finite or infinite? Infinite. And what we're going to do with this one is I want us to write it in sigma notation. So, do you remember what the first thing we do with sigma notation is? The first thing that we do always the same. N equals 1 on the bottom. Always, 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 always. Whenever we write it, we put n equals 1. At the top, I need to put how many terms there are. Well, if it has ... how many terms are there? Infinite. So on the top, I put infinity. So far, so good? What's the last thing I have to do for sigma notation? Over here, I put the explicit formula, right? And the explicit formula from yesterday is f of n equals f of 1 times r to the n minus 1. That's your explicit formula or explicit rule. Yeah? So, f of 1 is 2. What's my r value here? 2. We're multiplying by 2, right? How could I find that if it wasn't visually clear? 4 over 2, 8 over 4, 16 over 8, and all of these reduce to 2, which is how I get my r value of 2. So I put a 2 there, and I have n minus 1. Now, the biggest place where people make mistakes is they want to multiply 2 times 2 and call this 4 to the n minus 1. That's a problem. Because first off, that exponent has nothing to do with that 2. So if you combine that 2 with the other one, you're saying that exponent has to do with it, which is why you're putting it all together. That's the first issue. The second issue has to do with that up there. What does that say? PEMDAS. If I can't deal with an exponent, if I can't simplify something with the exponent, I can't move on to multiplication, division, addition, subtraction. I have to stop. Okay? So if I can't actually solve 2 to this power, I can't multiply anything in the problem. I have to stop right there. So that's what our sequence looks like in sigma notation. You getting sort of comfortable with sigma notation, hopefully? All right, I'm going to give you another one. I want you to write it in sigma notation. Okay, so take a minute and write this one right here in sigma notation. Bless you. Everyone should get that point, right? No excuses not to get that one. What number goes on the top? Why? 1, 2, 3, 4, 5, 6 terms. That's why we have a 6 at the top. Okay? Oops. Is my R value 1/2? So what's my formula that I write here? 12 parentheses 1/2 to the, and that's my sigma notation. And again, the only reason that arithmetic ones are a little bit more difficult is because we can't just go straight to here. We have to use that distributive property to combine our terms. It's the only thing that makes it different. Okay? All right. Next thing we need to know. We are going to get another new formula. We need to know the sum formula. Remember we had the sum of an arithmetic sequence? Or an arithmetic series, I should say. Remember that was n times the first term plus the last term divided by 2. This one is the sum of a finite geometric series. You ready? I'm going to highlight this because this is one of the formulas that we need. This one I think is the most involved formula. So, S of n equals f of 1 times 1 minus r to the n over 1 minus r. A little more highlighting there. So there's our new formula for today. Okay, you ready? So we're going to use the same sequence we used in this example right here. In example 2, 3 halves, 3/4, 3/8, and we're going to find the sum of those 6 terms. Now, with only 6 terms, I could technically plug 6 terms into my calculator, add them all together, and get an answer, right? But again, I want to show you how the formula works, and then I'll check it by doing that just to show you that it does end up being the same thing. So, the sum formula says that if I want the sum of all of these terms, how many terms are there? 1, 2, 3, 4, 5, 6. That means my n value is 6. So the sum of 6 terms is equal to, and I have this big old fraction here. On the top, I have the first term, which is 12, times 1 minus, what was the r value here? Okay. So it's 1 minus 1/2 to the what power? 6th power, all over 1 minus 1/2. Now that's kind of ugly to put into your calculator, right? And they're speaking to me in fractions, so I need to make sure that my answer is a fraction. But I actually think it's going to be easier to plug this in my calculator if I use 0.5. If I don't use 0.5, I'm going to have to put extra parentheses here as well as these parentheses here. So if I put parentheses in all of those places on the bottom as well, I should be okay in my calculator. Let's see. 12 parentheses 1 minus parentheses 1 divided by 2, or you could use your fraction button. Let's see if it likes my fraction button there. Close one parentheses, to the 6th, close another parentheses. So do you get that? I have the outer parentheses, and then the 1/2 is also in parentheses. Now I can press divided by parentheses 1 minus 1/2. 23 and 5/8. Let me change that to an improper fraction. 189 over 8. Let's see if that's true, because if it's not, then I did something wrong. Yeah? So let's see if I do it the long way. Well, the longer way. 12 plus 6 plus 3 plus 3 halves plus 3/4 plus 3/8. 23 and 5/8. I think that's the same thing, isn't it? 189 over 8. So, yeah, it's ugly. But if you think about it, there's only 3 nice numbers in that sequence. So you're going to get something ugly there. So? Questions about writing a geometric in sigma notation? Any questions there? Okay. Questions about taking a sequence and plugging it into the formula? The hardest part of that is actually plugging this into your calculator. And if you struggle with plugging it into your calculator, my advice is do just the numerator, hit enter, get to your answer, and then put divided by parentheses, whatever your denominator is. Okay? All right. Next one. Let's see. Am I going to need more room? I think I should be okay here. Let's evaluate a sigma notation. Okay, what is this problem asking me to do? There's no written instructions, it's just a sigma. Well, the sigma is telling me to do something. What's it telling me to do? Add up all the terms, right? Is it asking me to add up all 11 terms? No, it's asking me to add up the 5th term, 6th term, 7th term, 8th term, 9th term, 10th term, and 11th term. So what terms am I skipping? 1, 2, 3, and 4. So if there are 11 terms on the whole sequence, and I'm skipping 4, what is my actual n value? 6. You sure? I think it's 7. Because if I have 11 terms, take away the 4 that I'm skipping, I have 7 terms. Now again, that's tricky because your brain wants to just do 11 minus 5. But that would imply you're skipping 5 terms, and you're not. You're only skipping 4. Okay? So my n value is 7. What is my r value? Negative 3, right? R is negative 3. What's 12? The first term. So from all of this, I'm able to pull out that. So all I have to do is plug that into my sum formula, and I'll get my answer. So let's see. The sum of how many terms? 7 is equal to the first term times 1 minus negative 3 to the 7th over 1 minus negative 3. Now, on the bottom, this is going to turn into a plus 3, right? So the bottom I should be able to tell is going to be a 4. On the top, is that going to turn into a plus 3? Why not? Because of PEMDAS again. You have to do that exponent before you do the multiplication, and the multiplication is the step that gets rid of that minus and negative. So plug it into your calculator, being very careful. You will probably get a fairly big number, because we're adding together 7 terms, and the first term's 12. And it looks like it's increasing, so we're probably going to get a decently big number. So let's see. 12 parentheses, 1 minus another parentheses, negative 3 to the 7th. Make sure you close the negative 3 parentheses. Oops, you can't see what I'm doing. And the 7 parentheses. Divided by 4. Did I do that right? So what do I get? 6,564. I did something wrong there. Unintentionally, but I'll use it as a teaching point. What is wrong with my problem? Can anyone find it? Because this answer, way off. Where did I screw up? Anybody? Do you need help? No. I did. Mathematically, I've done everything correctly. One of my numbers is wrong. 12 is wrong. Why is 12 wrong? Because yes, 12 is f of 1, but if I'm starting with the fifth term, I need the fifth term right there, not the first term. Does that make sense? That's where my error is. So how do I find the fifth term? Let's take off that 12. Plug in 5. So I don't need f of 1, I need f of 5. 12, parentheses, negative 3 to the 5 minus 1 is 4. The fifth term is 972. I think my answer is going to be a little different if instead of 12, I have 972. Not technically, because it's hard to notate the first term in the part of the sequence you're doing. So you might make a little comment there that says first term of the ones you are adding. Does that help? Okay. So let's try this again, but instead of putting 12, so hopefully my mistake helps you if you make a similar mistake. That's where we learn the most is from our mistakes, right? And we put 972. And now let's see where our answer goes. Parentheses, 1 minus negative 3 to the 7th divided by 4. There we go. Much bigger number, isn't it? Because multiplying by 972 is a little different than multiplying by 12. Yes, ma'am.
Okay, so when you said that n won't be 6 because I don't understand what you got.
Okay, so in this sequence, if I were to write out this sequence, to get the first term, well, technically I know the first term. The first term is 12, right? So let me just explain this a little bit in depth so hopefully it'll clarify it all. So I know the first term is 12. If I didn't know the first term was 12, like in an arithmetic one, I plug in 1 there and I solve it, right? What's the second term? I would plug in 2 right there, right? So if I plug in 2, 12 times negative 3 to the 2 minus 1 is first power, it's 36. And because I know that the R value is negative 3, I can just keep multiplying. Hang on, that should be negative 36. I can just keep multiplying by negative 3, and the next term is 108. The next one times negative 3 is negative 324. And I could technically list out all 11 terms, couldn't I? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now, I'm not going to take the time to write in all of those terms, but you could if you needed to, right? Since they're saying don't start at the first term. If this was k equals 1, I would be adding together all of those terms. Since it says k equals 5, it's saying skip 1, 2, 3, 4, and only add terms 5 through 11. Well, if you count up terms 5 through 11, 1, 2, 3, 4, 5, 6, 7, that's where the 7 comes from. Okay? So you have to think about it in terms of how many are you skipping, because that'll tell you how many are remaining that you're adding together.
So when it's not 1, like you're always going to skip the number off?
Yes. Yes. When it's 1, you're going to keep it, but when it's not 1, that's the one you have to think this way. Okay? Does that help? I know that's tricky. It's simple when you get it, but it's tricky to get it there for a minute. Okay. Any other questions about that one? Everybody understand why I made a mistake there and we had to redo that part? Awesome. All right. Last type of question I want to show you. What number am I on? 5? I have 2 of these if we have time. What are we doing on time? Oh, we're doing good. Okay, so write the explicit formula. Did I talk to this class about what the other word for formula could be? It could say write the explicit rule. Rule is another word for formula. Okay? So, here's the information I'm going to give you. One little bit of interesting stuff that I need to include in the directions that I didn't is that I need to say it's geometric somewhere in the instructions. Because if I don't say geometric, it could be arithmetic, it could be neither, it could be anything. So there does have to be the word geometric in there. Okay? Now, do you remember from yesterday, if this is my explicit formula, f of n is equal to f of 1 times r to the n minus 1. What are the two pieces of information I need in order to write the rule? I need f of 1 and I need r. Once I have those, my equation is very easy to write. Do they give me either of those? No. Dang it. That makes my life more difficult. So on the arithmetic ones, we learned two different ways. We learned the slope method and the elimination method. Most of you found the slope method more user-friendly, right? Unfortunately, with these ones, well, the elimination method tends to be a little bit easier. I'm actually going to kind of show you, it's kind of a modified elimination method, if you will. So let's take this. If this is a point, and I plug it into here, what would it look like? What would I plug in for f of n? 40 equals f of 1 times r to the what? 3 minus 1. Okay? Can I simplify that? It really becomes 40 equals f of 1 times r to the second. Yeah? Okay, let's do the same thing with the other point. What does this one become? 640 equals f of 1 times r to the 7 minus 1, which simplifies to 640 equals f of 1 times r to the 6. Now, we are going to solve this using a system. It's the easiest way to do it. And these two equations right here, I'm going to write them down here, put the bigger exponent on top. Yes, you can still solve it if you do it the other way, but life's a whole lot easier if you put the one with the bigger exponent on top. So I'm going to put the 640 equals f of 1 times r to the 6th on top, and on the bottom I have 40 equals f of 1 times r to the 2nd. Okay? Now, to solve this the way you might know how to, you would probably use substitution. You'd get like f of 1 by itself in one of the equations, plug it into the other, but we're going to do division instead. What I'm going to do is I'm going to take the top equation and I'm going to divide it completely by the bottom one. So what is 640 divided by 40? 640 divided by 40 is 16. What happens when I have f of 1 over f of 1? It cancels. And what happens when I have 6 r's on top and 2 r's on the bottom? You subtract them and you get r to the 4th. How do I get r by itself now? Take the 4th root. What's the 4th root of 16? 2. Now technically there's actually two answers there. Positive or negative, because remember when you're taking that even index, you actually have two r values. Oh, I'll show you how to deal with that in a minute. So my r is plus or minus 2. Okay, so far so good? Yeah? Okay. Let's take, well, now that I know what R is, yes? When the index is even, yes. If I'm taking the cube root of something, there's only one answer. If I'm taking the square root, there's two potential answers. The fourth root, there's two potential answers. So only when this is even. Okay? All right. So now, yeah.
How did you get to...
Fourth root of 16. I can do that on my calculator. I can press 4 and then that x radical. Fourth root of 16. Now my calculator only gives me the positive one. So I need to remember that it's positive and negative. My calculator will only give me a negative if I put a negative in front of the problem. Okay? All right. So now I need to go find f of 1. Where do I go for that? One of these two equations. Pick the one that has reasonable numbers. I'm going to pick the one that has r squared instead of r to the 6th. Okay? So 40 equals f of 1 times r squared. What do I plug in for r? 2 or negative 2? Think about that for a minute. Does it matter? Because if I'm squaring it, they're both going to give the same thing, aren't they? Now, if this was like 2 to the, or if this was a third or something, I would actually have to do this twice. And get two different equations, basically. Right? So it's kind of like it's telling me there's two equations. In this case, since we're squaring it, we're going to get the same result no matter what. Because I'm going to divide by 4, and f of 1 is 10. Same thing would happen over here in this case. But you always have to check to see if you would get a different number, that's going to change things. So there is the potential of getting two different explicit formulas when you have this r value that's positive and negative. Now, since f of 1 is just 10, let's write our explicit formulas. We technically have two. We can say f of n is equal to 10 times positive 2 to the n minus 1. And then the other possibility is f of n equals 10 times negative 2 to the n minus 1. Why are there two possibilities? Well, let's think about this. When r is 2, and I'm multiplying by 2, and my first term is 10, I'm always going to have positive numbers, right? It's always going to be positive. If my first term is positive, my r value is positive, it's going to be positive no matter which term I'm looking at. When I have that negative r value, do you remember from the graph yesterday what happens to it? It goes back and forth, positive, negative, positive, negative, positive, negative. So the reason we have two possibilities is because the 2 points they've given me on that graph that goes back and forth, those two would be positive anyways. It would be the ones between them that would be negative. So we don't have enough information to know, is it a regular one with a positive 2, or is it one of those ones that bounces back and forth with a negative 2? Sometimes we will know and it'll be straightforward. Sometimes it'll be like that. So? All right, let me do one more of those with you. Hopefully it turns out a little bit nicer, but if it doesn't, we'll deal. So we'll call this our last one, number 6. F of 3 is equal to 10, and f of 6 is equal to 270. So again, this is geometric. Write your, or find f of n. So I'm going to give you a minute to work through that and see what you can do with it, okay? So I'm kind of quietly working through this with you. Is that what you got for your first equation? that what you got for your second one? Okay, and then what's the rule about stacking them up? Bigger exponent on top. And I'm going to divide. So what do I get? 27 equals r to the third. So how do I find r? I cube root it. So what does r equal? Is it a plus or minus circumstance? No, so life's easier here. I only have one r value. How do I find f of 1 then? Go back to one of these two. Typically it's easiest to go to the one with the smaller exponent. So let's see, 10 equals f of 1 times 3 squared. Yeah? So 10 equals f of 1 times 9. Divide by 9. And that doesn't reduce nicely, but we'll just call it 10/9. If you could reduce that fraction, reduce it. So I have r, I have f of 1. What is my formula? F of n equals 10/9 times 3 to the n minus 1. That's my explicit formula. So it's much simpler when we have odd indexes and we don't have to worry about the plus or minus thing. Okay? Questions? All right, your homework is posted. Happy studying.